identities. So until now we've been dealing with, let's say, sine of x or sine of y, separate angles, like individual angles, like, right, sine of x. We've been talking about sine of y or cosine of x, cosine of y. Now we want to find out what is sine of x plus y equal to. So here I drew two angles, the red angle's y, the blue angle's x. And I want to find out how I can express their sum in terms of those four different angles over here. So how can I break up the x plus y? And to do this, I'm going to take the first blue angle and I'm going to measure off 1 over here on the side. And I'm going to draw a right triangle. So if you notice, now I have a blue right triangle with a hypotenuse of 1. And from this point where I ended, I'm going to draw another triangle, red one. Both of them are right triangles. So I know that, for example, the red line is sine of x. Sorry. And however, I'm not really interested in those angles separately. What I want to know is when I combine them as x plus y, so I'm going to create a green triangle over here. When I combine x plus y, what is sine of this combined x plus y angle? So let's just give some letters so that we can A, B, C. And I actually need to create one more little side which will help me to find what I'm looking for. I'm gonna call this D, E, F. And this little dot here I'm gonna call Q. So what I'm looking for is really sine of x plus y. So let's see what sine of x plus, how we can express it in terms of those lengths. Okay, so sine of x plus y is really this equal to, let's look at this greenish triangle over here, A, F, D. So we're looking at triangle A, F, D. And in it, we notice that sine of x plus y is the opposite side to angle x plus y, which is df, over hypotenuse of 1, which is AD. So bottom line, if we are able to find df, we will be, in terms of sine of x, sine of y, cosine of x, cosine of y, we've found our identity. Let's notice that df is really equal to two segments, which is de plus ef. Also, you may notice that EFBC is a rectangle, therefore sine EF is really equal to sine CB. So this entire problem becomes a problem in which I'm looking for DE and CB, and I want to express them in terms of sine of x, sine of y, cosine of x, cosine of y. And if I do that, I found my identity. I'm going to start with the blue triangle over here. So in triangle ACD, what I notice, I'm going to try to express all of these sides in terms of the angle, sine and cosine. So in this blue triangle ACD, what I notice is the angle across, the side across from x is DC. So I'm going to say DC is equal to, I'm going to start with sine of x is equal to the opposite side DC divided by AD, which is the hypotenuse, and the hypotenuse is really 1. So I know that sine of x is equal to DC. I'm going to write here sine x. Okay, great. Now I can look at triangle ECD, and maybe I can find the length DE somehow, but I don't know any of the angles. So I'm going to look for DE using the little triangle EDC. The problem I've got though is I don't know any of the angles. I just know this one's a 90-degree angle. So here's what I'm going to do. I'm going to use that red angle here, the Y. I know all angles in a triangle add up to 180. So let's look at the little red triangle AFQ here, right? This one. And I notice this is 90, this is Y. So therefore, if all of them you have to add up to 180, this one has to be equal to 90 minus Y on this side. On this side, this is a vertical angle. Those two angles are actually across from each other and they're equal. So this one is going to be 90 minus Y as well. Well, guess what? If you actually look at now QCD, again QCD, it's also a right triangle. One of the angles is 90 minus Y, the other one's 90. So this angle up here has to be equal to Y. Okay, now I can go back and I can continue over here, because what I notice is that the side I'm interested in, this side in particular, DE, it's adjacent to angle Y. Therefore, I could use the cosine ratio, and I'm going to say cosine of Y is equal to DE over the hypotenuse DC. Well, the hypotenuse is really equal to sine of X. Now, I want to eliminate sine of X on the bottom, so I multiply both sides by sine of X. It eliminates, and I end up with DE is equal to sine X cosine Y. Oh, great. So I'm going to go up here, and instead of DE, I'm going to say sine X cosine Y. Now, that's great. I'm still missing this side CB. I need to find it. So I notice that CB is actually an opposite side of angle Y. But to use the trig ratios, I need to know the length of the hypotenuse. Well, also the length of the hypotenuse is also in triangle ABC. In the red triangle, AC is a hypotenuse, but in the blue triangle, AC is a leg. It's a leg, it's a cateto, right? So let's go back to the blue triangle. Okay, and if I look at the blue triangle, I'm gonna write here in triangle ACD. Now I'm trying to express side AC, and it's adjacent to angle X. Adjacent means let's use cosine, so I'm going to say cosine of X is equal to AC over hypotenuse AD, which is 1, which is equal to AC. Great, now I know that this thing over here, the blue-red thing, line AC, is really cosine of X. I'm going to now look exclusively in the red triangle. So I'm going to say in triangle ABC, what I'm trying to express is side CB. Side CB is opposite angle Y. Therefore, I'm going to use the sine ratio. I'm going to say sine of Y is equal to CB over hypotenuse AC. Well, we already saw that AC is cosine of X. Let's say this little red thing. So I'm going to use this information here, and I'm going to say sine of Y equals CB, and instead of AC, I'm going to write cosine X. I want to eliminate cosine X from the denominator. I multiply both sides, and I get CB is equal to cosine of X sine Y. Oh, great, I just found CB. Therefore, instead of CB, I'm going to write here plus cosine X sine Y. And we remember that DF is equal to sine of X plus Y. So I found that this side over here is equal to this side over here. Therefore, I just found the some angle identity for sine. What happens if instead of adding angles, I want to subtract them? Okay, so let's see what's going to happen. I'm actually going to use the identity I just found, but I'm gonna write a minus and y. And I also realized that I can rewrite this. I can really say sine of x minus, sorry, I need to pause for a second. Okay, we're almost at the end. So, and here I'm just gonna think of this as a positive, sorry, I'm going to just imagine that there's a plus in the middle and I'm adding a negative angle to x, okay? So I'm gonna use the identity above. I'm gonna substitute y with minus y, and here's what I'm gonna get. Sine of x cosine of minus y plus cosine of x sine of minus y. Now, here what comes very useful is the even and odd identities. If you remember, cosine is an even identity, so this minus really doesn't matter. The output of a negative or a positive angle will always give me the same output. So cosine of minus y, right, if you remember, cosine of minus y is equal to cosine of y. And now here, if you remember here though, sine is an odd identity, therefore the minus is going to come outside. I cannot ignore the minus, right? Because a positive and a negative angle are going to give me outputs which have different signs. So the minus is going to come outside, and what I really get here is sine x cosine y, and the minus comes out minus cosine x sine y. So I proved not only the addition identity, but also the subtraction identity. I know that's pretty long. I hope you had the patience to carry through with it. Please take notes, and this will be highly proficient if you're able to reproduce this proof and fully understand it.